Welcome. What I want to do today is show you how to graph the exponential function y equals 1/2 times 5 raised to the x. So the main important thing we want to look at when we're trying to find an exponential function is, or at least graphing it, is we want to understand what the behavior is. And one thing we need to remember about exponential functions is they grow very, very rapidly. That's accentuate the exponential growth, and they also shrink down very, very rapidly. So the one important thing that's a characteristics of exponential graphs is that it has a y-axis at 1. I'm sorry, not a y-axis, a y-intercept at 1 for our parent graph. Which looks something like this. All right. And the reason again why it has that y-intercept at 1, 0, comma 1, is if I was going to plug in my x value of 0 into my function, a to the 0, or as a represents any number, is always going to equal 1. So that's one thing I always remember about my exponential functions. Now, however, this problem, I have a little bit of some transformation. I have here, or not translation, I have my 1/2 times 5 raised to the x. So what I can determine is there's some things that are actually happening with this graph that it might be a little bit different than what actually the parent graph is. So what I'm going to do is, the first thing, I'm just going to kind of create a table to help me out. And the first thing I'm going to want to do on my table is see if I can determine what exactly are the x and the y or not the x and y, but let's just figure out what the y-intercept is, and then once I figure out the y-intercept, I'm going to pick a point to the left of it and pick a point to the right and determine where those points are. That will help me kind of guide the path like I did for the parent graph. So the first thing is, let's get the easy one out of the way. Let's determine what is our graph looks like at x equals 0. So I'll simply just say y equals 1/2 times 5 raised to the 0 power. Remember, any number raised to the 0 power equals 1. 1 times 1/2 equals, 0, equals 1/2. So now I go over to my graph, and I'd say, well, at 0, I'm going by 2's here, so 1/2 is going to be close down, right down there. All right? And you can see that I have a really big graph, and why do I have that? You'll see in a second. The next one is, now let's pick a point to the right, and let's pick a point to the left. So a point to the right, I'll pick 2. So let's say x equals 2. So here I have y equals 1/2 5 times 2. Well, 5 times 2 is 25. And then 1/2 of 25 is roughly going to be 12.5. So I go over 2, and I go up to, there to be 12, there to be 13, so 12.5 is roughly going to be somewhere around there. And the last one, let's just take a look at x equals -1. Now, we could fill in a lot more table values, and if you look at what 3 would be, that's going to be f to the, or 5 to the 3rd power, which would be 125. Divide that by 2, and we're going to already start to get off of our graph. So that's why I'm just very cautious, we can get the basic relationship or shape of the graph just by choosing our 3 points. One, our y-intercept, and then 1 point to the right and 1 point to the left. So if I pick x equals -1, I get y equals 1/2 times 5 to the -1. Now remember, 5 to the -1 equals 1/2 of 1 over 5. As the negative exponent tells me to put in the bottom, I multiply my fractions, and I get 1 over 1/10. Now, I got kind of this fat little marker here. It's going to be very hard for me to write in where exactly 1/10 is. But you can see it's going to be very, very close to 0. So this graph is going to grow very, very exponentially and then get very, very close to 1 very, very soon. But either way, you guys can see how the graph looks when you're graphing y equals 1/2 times 5 to the x. Thanks.